This is the Unit 1 test review guide for Algebra 2. We'll start with number 1. Given f of x equals 3 minus 5x, we want to evaluate for when x equals 7. If we're looking at when x equals 7, we want to rewrite the function with the 7 where the x is in between the parentheses. So we write f of 7 equals 3 minus 5, and then we're going to also replace the x with the 7, so 3 minus 5 times 7. You're going to type it into your calculator exactly like that, 3 minus 5 times 7. When you type 3 minus 5 times 7 into your calculator, you're going to get the answer negative 32. But remember that we're working in function notation, and so you're going to write your answer as f of 7 is equal to negative 32. Number 2, given f of x equals 4x squared minus 2, we're going to evaluate for when x is equal to negative 5. If x is negative 5, then we're going to replace the x, both in the parentheses and where the x squared is, with that negative 5. So we're going to write it as f of negative 5 is equal to 4 parentheses negative 5 close parentheses squared minus 2. It's very important that you put the parentheses around the negative 5 and that you put the squared outside of the parentheses. When you type this into your calculator, you're going to type it exactly like that. 4 parentheses negative 5 close parentheses and then the x squared minus 2. If you don't use the parentheses, you'll get the wrong answer. Once you've typed this into your calculator, you're going to have f of negative 5 is equal to positive 98. If you got negative 102, you didn't use the parentheses correctly. So double check how you've typed that in. Number 3, evaluate f of x equals 6 plus 8x cubed when x is negative 2. So f of negative 2 is equal to 6 plus 8 times negative 2 to the third power. Type that into your calculator exactly like this, with the parentheses around the negative 2 and the third power outside the parentheses, and you will get f of negative 2 is equal to negative 58. In number 4, remember that when you're given a number that is inside the parentheses of the function notation, that is an x value. So we're going to consider that to be an x value. Let me put a little x there. And you're going to look at each of the x values in these ordered pairs above and look for the one that has an 8. And the y value that corresponds to that particular x value is going to be the answer. So f of 8 is equal to negative 3 because negative 3 is the y value when the x value is positive 8. Now in number 5, you're working a little bit backwards. It's asking you when g of x equals negative 3, and that negative 3, because it's after the equal sign, is going to be a y value. And so let's write a little y over here to remember that. And we're going to look at each of the y values to see where one of them is negative 3, and it would be this last ordered pair here. And so the x value that corresponds is going to be the x value of our answer, so x equals 7 from that x value right there. Now, in number 6, we're going to be using that graph, and we're given either an x or a y value and asked to find the opposite. So here in part A, we're looking to find f of negative 5. Negative 5 is inside the parentheses, therefore it's an x value, and so we want our answer to be a y value. So I'm going to look at the graph. find where x is negative 5 on the x-axis, so x is negative 5 here, and then I'm going to look at the graph right there, and the y value that goes with that is y equals positive 3. In the next problem, I'm given that f of x equals 3, and so because the 3 is after the equal sign, that is a y value. I hope you didn't see all that in the video. This is a y value, and so I'm going to find where y is equal to 3. Well, here's y is 3, and I'm going to look across the whole graph, because when you're given the y value, you might have multiple x values that correspond. These two x values are negative 5 and positive 10, and so in this case, I'm going to have two answers, negative 5 and positive 10. And then in part C, f of 0, that 0, again, is an x value because it's inside the parentheses, and x is 0 is here, so the graph equals negative 3 when f of 0 is the question. Does this graph represent a function? To decide if a graph represents a function, let me get rid of all of this stuff here, you want to do the vertical line test. So we're going to look at all the places where we could draw a vertical line on this graph, and if there's nowhere where I would cross the graph twice, then yes, it represents a function because it does pass the vertical line test. Number 7. We're given this graph and we're asked to find the domain and the range. So the domain, remember, is all the x values. And you want to think about it from left to right. What's the leftmost x value on this graph? Well, it's negative 4. But look that the graph goes all the way to the edge of the graph space, and remember that that assumes that there's an arrow there, and so that graph is going to keep going forever to the right. And so this domain goes from negative 4 to positive infinity. Remember that you need to put either a round parentheses or a square bracket at either end of your interval notation. Infinity will always have round parentheses, but the negative 4, because at that point x is equal to negative 4, we're going to put a square bracket there. And now the range, remember that your y values start here at the bottom and keep going up forever. Remember that the range is about y values, so that y value is y equals 0, and it goes up forever to positive infinity. Again, infinity will always have a round parentheses, and the 0 will in this case have a square bracket because y equals 0 at that point. It's a function, yes, because it passes the vertical line test. And to answer a couple of function-related questions about this, f of negative 4 is asking you to look at the x value negative 4 and answer with the y value that corresponds. Here is x equals negative 4 and the y value is 0. The other question gives you the y value that's 3, and you want to find the x value that corresponds to where y is 3. Y is 3 right here, and so the x value where y is 3, x equals 0. In number 8, remember that if it goes to the edge of the graph, you can assume it goes forever. And so this graph is going forever left and forever down. That's this end. And forever up and forever to the right. That's this end. And so both the domain and the range are negative infinity to positive infinity. And it is a function because it passes the vertical line test. Now, to answer the questions about the function values, -3 is given to you as an x value because it's inside the parentheses. And so if I look for x equals -3, which is here, the value of the function is y equals +1. And if I'm, in the next part, if I'm given f of x equals -2, -2 is a y value. So I want to find where y is -2, which is right here. And there's two places where it crosses the graph, at x equals 0, and let's say x equals -4.5 or -4.5. So you'll have two answers for that last part. Number 9, the domain, remember, goes from left to right, and so I'm going to look for the leftmost point of my graph, and I want to give the x value. So that x value is -4, and the rightmost end of my graph is right here. There's no points to the right of x equals 1, and so we're going to write -4 to +1. This touches right there, I've obscured it, but that touches x equals -4, and so that's going to be a square bracket around -4. And then at the other end, there is a point at x equals +1 right there. And so we're going to say square brackets for both the -4 and the 1. Now remember that the range goes from bottom to top. So the bottom of the range is here, the top of the range is here. You're looking for those y values. Here, y is -2. Here, y is +4. And so we're going to start by writing that the range is unbroken, by the way, between -2 and +4. There's no gaps there. And so we're going to give the range as being from -2 to +4. But notice at the bottom that the graph comes close to -2 here, but because the circle is open, when we answer that, we're going to put round parentheses. But at the top, because the circle is closed, up at that y equals +4, we're going to put a square bracket. It's not a function because it fails the vertical line test. If I were to draw a vertical line in certain places, it touches the graph twice, and that automatically means that it's not a function. Okay, number 10. Remember that the domain looks at the x values going from left to right. So we're going to start with the leftmost x value and go to the rightmost x value. And in this case, our leftmost x value is at -1, and our rightmost x value is at +5. Now, if you look at the -1, where x is equal to -1, that's an open circle, which means that it's not filled in. And when you have an open circle, your interval notation is going to have round parentheses. But at the other end, where x is +5, that is a closed circle. And so when you show a closed circle interval notation, you're going to have a square bracket. Now, to look at the range, remember that the range goes from bottom to top. And some of these graphs can be just a little bit confusing because your brain wants your eyes to move from left to right. But remember that the range starts at the bottom. And so in this graph, the bottom is here and goes to the top. And in this graph, the top is here. And then you want to look at the y values. So in this graph, your bottom y value is -2, and your top y value is +4. And so your range is going to go from -2 to +4. And at the bottom, the -2, y equals -2, is going to have a square bracket because it's a closed circle. And at the top, where y is equal to 4, you're going to have round parentheses because it's an open circle. It is a function because it passes the vertical line test. And this question here is a bad question because x doesn't equal -4, and so you could say maybe undefined. That was teacher error for sure. And then for f of x equals 3, here 3 is a y value, and you want to find the x value that corresponds with y is 3, which is right here, and there x is equal to 0. In number 11, that's a little bit tricky. We won't ask you a question like this on the test, but you can handle this domain and range if you work slowly. Remember that the domain goes from left to right, and on both ends of the graph, that graph keeps going forever, and so on the left, it's going from -infinity, but there's this missing x value right in the middle where we've got that dotted line, and that missing x value is x is equal to 2, and so 2 is missing from the domain. So when we write the domain, we're going to say -infinity to 2, but not including 2, and then 2 to +infinity, but not including the 2. The range is going to work the same way, except that we're missing this y value, and that y value is y equals 3, and so that's going to be your missing y value. So the range goes from the bottom at -infinity to +3, but not including 3, and then from 3 but not including 3, all the way up to +infinity at the top. Yes, it is a function. And then if you want to find the value of the function at certain x and y values, that works the same way as the other functions that we've looked at. So f of 1 means where's the x1, and that's going to be right there, and the y value is 2. And then in the next question, you're told f of x equals 4, and so that's a y value. You want to look at where y is 4, and the x value for that is +3, and so your answer for that part is 3. Now, number 12 looks all crazy and everything, but it's not really that bad. Remember that you want to start from left to right, but notice that in the middle of the graph, there's a place where there's no x values. So in that little sliver between x equals 2 and x equals 3, we don't have any x values. So we're going to write our domain as 2 parts. And we're going to start by looking at the domain of this part, and then we're going to look at the domain of this part. So to start with the first part, it goes from left to right, and on the left it's -7, and on the right it's +2, -7 with a square bracket because of the closed circle, to +2 with round parentheses because of the open circle. And then the domain of the second part starts at +3 and goes to +5, 6, 7, 8, so from 3 to 8. So from 3 to 8, square bracket around the 3, open parentheses around the 8, and then we write the union symbol between to say that there's 2 parts to our domain. Now, the range works a little bit differently. Don't get confused though. So the bottom, very bottommost point on this graph, y values, is right here where y is -4. And the highest y value at the very tip-top most part of this graph is where y equals positive 4. And if you look all the way through the graph, there's no place where you're missing any y values. Because even though the graph is broken here, those y values are accounted for over here. So we have y values everywhere from negative 4 to positive 4. And so our range is going to go from negative 4 to positive 4, and because of this closed circle, and because of this point touching, both ends of the range are going to have a square bracket. Now, all of that mess up there that I seem to not be able to erase at this point is a function. Yes, it passes the vertical line test. And f of negative 4 is going to be at that point right there. So y is positive 4 when f is negative, f of negative 4 is positive 4. And then when y is negative 4, that would be right here. That point as an x value then is going to be negative 7. Negative 7, when x is negative 7, y is negative 4. Number 13, you're given this graph and this graph here, and you're given a domain and a range and asked if that answer is correct. And so the domain assumes, remember that we're supposed to assume that the graph keeps going forever if it goes to the edge of the graph space. And whoever wrote this domain didn't make the graph keep going, and so they incorrectly wrote that the graph stops on the x-axis. So it should be from negative infinity to positive infinity. Remember that we call that all real numbers. For the range, the numbers are correct. The graph at the bottom is y equals negative 4, and it goes up forever, so it goes up to positive infinity. But remember that positive infinity or negative infinity always have round parentheses. And in this case, because the graph equals negative 4, at that point the y value is equal to negative 4, that negative 4 is going to have a square bracket. Now in number 14, we want to circle all of the graphs that have a domain that is from negative infinity to positive 4 and including positive 4. Now be careful of that. It has to include x equals 4. Has to be included in the graph. Now, in this first graph, that's the problem, because at this end, it does start at negative infinity on the left, but here, that negative 4 would have to be around positive 4, x equals positive 4 would have to be around parentheses for it to be that graph. So this graph does not fit the criteria negative infinity to 4, including positive 4. But this next graph, on the left is negative infinity, on the right is 4 with a square bracket, and so this graph is one of our answers. The next graph, remember, goes down forever and up forever, and it also goes left forever here and right forever there. And so on the right, it doesn't stop at 4, therefore this graph is not included in our answers. This last graph on the top row goes to the left here and here forever. So negative infinity on the left. And here at 4, the x value equals 4 right at that point. So the domain is negative infinity to 4, including 4. And so this graph is also one of our answers. So far, the second and the fourth graphs. Let's look at the bottom row. Remember that your domain is your x values. Here on the left, you go to negative infinity. On the right, you go to positive infinity. And so this graph, doesn't end at 4, and therefore it's not one of our choices. This graph is slightly tricky. On the left, it goes to negative infinity. On the right, it goes to x is 4, but because of this asymptote here, the domain would be negative infinity to 4 with a round parentheses, not with a square bracket. So this graph is also not one of our correct answers. In this graph, the domain again starts at negative infinity on the left. On the right, this point is included in the graph, and that's 1, 2, 3, 4. That point is x equals 4, and so the domain is negative infinity to 4, including 4, and so this graph is also one of our answers. And in this last graph, again, even though it's going very quickly down, it's also going somewhat to the left and somewhat to the right forever. So the domain is negative infinity to positive infinity, and therefore this is not one of our answers. So to recap, you've got 3 graphs that fit the criteria, and those would be the second graph, the fourth graph, and the 7th graph, those 3 graphs. Now, we have to write this statement in interval notation. All numbers from, but not including, wait, those are important words, not including -8 up to and including 13. Well, let's start with the -8 to 13 part. So -8 to 13. The not including -8 is round parentheses. Including 13 is the square bracket. And in number 16 is a little bit like number 12 if you wanted to pause and go back and look at number 12 again. The reason that it's similar is that when you look at the domain, there are x values missing all the way from -1 to +1. And so when we write our domain, we have to write the domain in 2 parts. And so we're going to look first at the part over here, and we're going to say that that domain is from -5 to -1. The -5 has a square bracket because -5 is an x value that's included in the graph. The -1 has round parentheses because the x equals -1 has a round or an open circle, meaning that -1 is not included in the graph. Remember your union symbol, and then the second part of the graph here, you're going to go from +1 to +3. The +1 has round parentheses because it's an open circle. And the +3, remember it's +3 because that's where x is 3, has a closed or a square bracket because it's a closed circle. Now, looking at the range, you want to find the bottommost point and the topmost point. The bottommost y value is here, and the topmost y value is here. And so that bottommost value is at y equals -1. There's no breaks in the graph as you go up from -1 to +5. You're not missing any y values. And so from -1 to +5 is all one interval. Round parentheses around the -1 because there's no y equals -1. It's an open circle. And then a square bracket at +5 because the graph touches y equals 5, and so y equals 5 is included in the range of y values. Now we'll move on to graphical characteristics. We'll start with this first graph. And remember that we won't ask you on this unit test about any graph that has an asymptote, but we will in the future. That will be probably around February or so that we'll start looking at graphs with asymptotes. In the meantime, I can tell you that this graph has an asymptote here at y equals -4. And that the function family for this graph is the exponential function. The domain of this graph, on the left, that graph keeps going to the left forever, and on the right, it keeps going to the right forever. So the domain is -infinity to +infinity. And the range of the graph starts at the bottom where the asymptote is. So the bottom of the graph is right here at y equals -4, and at the top it goes up forever. Now it goes from -4 to +infinity, but because it's an asymptote, the graph actually doesn't ever touch y equals -4. The local max and min, there's no place where the graph is going down and then turns around and comes up, or is going up and then turns around and comes down, and therefore there are no max or mins. The graph is increasing everywhere, and that's a little bit more difficult to see on this graph because of the asymptote and how close the graph is at the asymptote. But if you start on the left and work your way toward the right, if you're an ant crawling on that blue line, you're always crawling uphill, even if it's slightly. So what we're going to do is we're going to look at the domain, all real numbers, and we're going to say that if the graph is increasing over the entire domain, that the increasing interval is the same as the domain, so -infinity to +infinity. And if the graph is increasing everywhere, then it is decreasing nowhere, so there is no interval of decrease. There's one x-intercept and one y-intercept. You can see the x-intercept here and the y-intercept here. And so those values, remember, we're going to write them as ordered pairs. And so the x-intercept is approximately 3.30, and the y-intercept is going to be about 0, -3.9, let's say. And remember that x-intercepts and zeros should have the same number part, but they're just written differently. So your 0 is going to be x equals 3.3. For end behavior, remember that the way it reads is this asks you what's happening on the right, because x goes into +infinity on the right. And this part asks you what's happening on the left, because x goes to -infinity on the left. So in the graph on the right, the graph is going up forever. And so your end behavior on the right is +infinity. On the left, it's not going down forever, it's just getting closer to that -4 forever. And so when there's a horizontal asymptote, one or both ends of the end behavior are going to be equal to the horizontal asymptote. So in this case, on the left, the graph goes to -4. Now, on your test, the question that has the graphical characteristics will be more like this, either a quadratic graph or an absolute value function or a linear function, one of the more basic functions that doesn't have an asymptote. So this function family, because it's U-shaped, remember that the U-shaped graphs are going to be the quadratic functions, so this is quadratic. It's going forever left and forever right, so the domain is -infinity to +infinity. For the range, the bottom of the graph, because it's going forever down as well as forever right and left, the range of the graph starts at the bottom at -infinity. But it goes to the top right here at that place, and so that's going to be y equals +3. but you're going to put a square bracket around 3 because this point right here has the value y equals 3. Now, that point is also a local maximum. The ordered pair that represents that point is 1, 3. And so we're going to say that we have a maximum at the ordered pair 1, 3. Now, remember that most of you are okay with pointing to a part of the graph and saying, yeah, this is increasing, yeah, that's decreasing. So let's just start by highlighting. And let's highlight the increasing portion of the graph with red or pink. And that's going to be the increasing portion of the graph. And then let's highlight the decreasing portion of the graph with green. I also know that some of you maybe have been writing in whether it's increasing or decreasing next to that part of the graph. So we could say here that it's increasing here to this point, and then on the other side of that point, it's decreasing. Once you have decided which part of the graph is increasing and which part of the graph is decreasing, you want to look just at the x value where it changes. So right here, we had said that that x value is 1, so x equals 1 where it changes. So now we're ready for our intervals of increase and decrease. And we're going to say that it's increasing from x is negative infinity to x is 1. And it's decreasing from x is 1 to x is positive infinity. Don't be confused that your eyes are going down here. It's all about what's happening on the x-axis, and remember that on the x-axis, it's not going up or down, it's going left or right. That's a tricky concept. So, I'm going to, at this point, erase all those scribbles on this graph. I think I'm going to erase all those scribbles on this graph. Here we go. So that we can talk more about the x and y intercepts. And so I see here x-intercepts, 2 of them, and 1 y-intercept. Remember that x and y-intercepts are different things and you have to state them separately. So I'm going to say that those x-intercepts, and you can just approximate the decimals there. Don't give whole numbers because they're not at whole number locations. But let's approximate the x-intercepts at negative 1.50. Remember to write that as an ordered pair. And how about 3.30? And that y-intercept, how about 0, 2.4? Remember that your x-intercepts are going to have a 0 for the y value, and that your y-intercept is going to have a 0 for the x value. That's by definition. The other thing that you want to remember is that your zeros and your x-intercepts are both going to have the same numbers. And so here, my zeros are going to be x equals negative 1.5 and positive 3.3. Now in this graph, both ends of the graph go down, and so I'm going to say that both end behaviors are negative infinity. Now this question at the bottom asks you to get just a little bit more creative. It says that you are going to want to draw a graph, and it doesn't give you much direction other than to say that the end behaviors both go down, so both ends of the graph are going to point down somehow, and it has a local maximum at negative 2, 4. So I'm going to put a maximum at negative 2, 4, which is right about there. And it doesn't matter what function. It could be absolute value, it could be quadratic, but what I have here is a graph with a maximum at negative 2, 4, and both end behaviors going down. So remember here that the only questions I'm going to ask you that are going to deal with function families are going to be either linear, absolute value, or quadratic on the test. Those are the three that I want you to be able to identify. But we've talked about some of the other ones in class, so I've given you on the review guide a few more than what we'll actually test you on. The only function family that is V-shaped is the absolute value function. I see a clear V shape here, even though it's flipped over, and so I'm going to say that this is the absolute value function family, and that the parent equation of that graph, parent equation, that's not the equation of the graph that you see here, but the parent graph is f of x equals the absolute value of x. Any of the functions that come in pieces that we're studying in Algebra 2, this graph happens to have 3 different parts that you can see. That's going to automatically be a rational function. And the equation of that parent function is 1 over x, where you have x in the denominator. A straight line with nothing else going on, no twists, no turns, no sharp corners, goes on forever in both directions. That's going to be a linear function. And the parent equation for that function family is just f of x equals x. And for this last one here, the graphs that tend to be wavy in the middle are the polynomial functions. And the parent equation of a polynomial function is x with an exponent. And if you're not sure what the exponent is, you can just say x to the n power, and n represents some number. But just for future reference, this graph is most likely a 4th degree graph, or x to the 4th power. We might call that a quartic graph, but we'll get into that in Unit 5. In this next question, it asks you to look at all of the function families of the equations on the right that are the same function family as the graph on the left. So for example, I see the graph on the left as a quadratic function. Quadratic function has an x squared in it, but no exponent bigger than x. So over here, well, it can't be the first one, that's absolute value. It can't be the second one, there's no x squared there. But the third one has an x squared and no higher exponent on an x. This next one is a logarithmic function. This next one has x's in a denominator, and so therefore anything that has an x in a denominator is going to be a rational function automatically. And so that is not a quadratic function. This function has an x cubed, so it's not quadratic. But this function has an x squared, but no higher exponent. This next function has an x as an exponent, but not an x with the power of 2. So it's not this one. And this last function has the x inside of a radical, so it's not that one. So your answers for this question are just this top left, or top right, and the bottom left. Now let's move on to some transformations. If you look at this equation, you should see three things. You see 32 multiplied out in front. You see an 18 added inside of parentheses. And you see a 92 subtracted outside of the parentheses. Now we're going to go from left to right. So let's start with the 32. And a number that's multiplied outside of the function or in front of the function is always going to be either a vertical stretch or compression. 32 is a number that's bigger than 1, and so if it's bigger than 1, it'll be a vertical stretch. If it's smaller than 1, it'll be a vertical compression. And remember that you have to give the stretch or compression factor, and that's the same number. So the green that I highlighted is the vertical stretch with a factor of 32. As you move to the left, or from the left to the right, you see that the 18 is added inside of the parentheses. And so when you are looking inside the parentheses, keep in mind that insiders lie. And since we're having a number that's added here, then that's going to tell us that it's a shift to the left. And you tell us how far you shifted to the left. So shift left 18. Finally, the 92 is outside the parentheses. And so if a number is added or subtracted outside the parentheses, that's going to be a shift up or down. And since outsiders don't lie, then that's going to be a shift down 92. So in 23, we have a parent graph that's an absolute value function. It's this V shape. And you are going to draw a transformed graph that moves 3 spaces to the left. You might want to write that in for yourself. Shift left 3, insiders lie. And it has a shift down of 4, outsiders don't lie, and no other transformations. So what I'm going to do is I'm going to take what was the vertex or that center point of the original graph, and I'm going to start by shifting that left 3 and down 4. So if I go to the left 3 and down 4, my new vertex is going to be right here. And then I'm going to draw the rest of the graph kind of facing the same direction because we don't have any flips, and the same shape. So grab that V shape again. And that's going to be your transformed graph. Shifted left 3 and down 4. So for numbers 24, 25, and 26, we're asking you to get just a little bit creative. We're going to ask you to choose one of the function families, draw a graph of the parent function, and then on that same graph, draw a transformed function. And then we tell you what the transformation is that you're going to do. Choose straightforward functions that are fairly easy to draw. Okay, no need to show off at this point. I'm going to start with the quadratic function family. And the quadratic function family, remember, has the equation. I didn't spell that correctly, did I? Quadratic, my apologies, equation of the parent function is f of x equals x squared. F of x equals x squared is a U-shaped function that has its vertex or its minimum at the origin. And then the transformation that we're going to make asks you to shift it right 2 and up 1. And so I'm going to do this in a different color. If I take the vertex of that graph and go right 2 and up 1, the transformed graph is going to look like that. The next one that I'm going to choose here is the absolute value function family. Remember that that's the one that looks like a V. And the parent equation for the absolute value is f of x equals the absolute value of x. That has its vertex at the origin and has the two, well, that wasn't very straight. It has the two straight line sides in both directions. Now, the transformation that we're asking you to do is a vertical compression of 1/2 and shift down 2. So I'm going to take the vertex of the original function, the parent function graph, and move it down 2. This vertical compression of 1/2 is hard to draw, and we'll look at that more in depth in Unit 2. But basically what you're going to do here is you're going to change the slope of the lines that are the sides of the graph and compress the graph that way, like this. Okay. And then in the third one, I'm going to do the square root function. You might want to do all three of them, quadratic or absolute value. Those I think are the easiest to see the transformations. But I'm going to do the square root function family. Remember that the square root function is the only one with an endpoint. And so the parent graph or parent equation of this function family is the square root of x. And the graph of the parent function starts at the origin 0, 0 and has points at 1, 1 and 2, 4 and goes like that. And the transformations that we're asking you to do are to flip it and have a vertical. In fact, let me back up just a second and talk about that. This negative at the beginning means to flip it over the x-axis. And the 2 is separate from the negative. That means that it's a vertical stretch of 2. And then the plus 1 inside the parentheses means that it shifts left 1. So I'm going to take that. I'm always going to start with some kind of a midpoint or the point on the origin or something that is an obvious part of the graph, and I'm going to do my shifts with that point, so it shifts left 1. So my transformed graph is going to shift left 1, and it's going to open down because of the flip. It's going to make it have a downward direction, but it's also going to stretch, which means that it's going to stretch away from the y-axis. So instead of being close in like that, it's going to actually be wider out like that. Okay. So there's 3 different functions with some of the transformations that you can do with those functions. Now let's move on and look at some of the inverse. Remember that we have a 4-step process for inverse. You need to show all 4 steps to get credit for these problems. And the first step says to take a function that's given in function notation like this is and rewrite it in y equals notation. So don't change anything else, just change the f of x to y. Copy the rest of the equation. And the next step is to exchange the x and the y. Don't change anything else. Just rewrite this as x equals 7y plus 1. And then the third step is to get the y alone. So now I want to get the y alone, so I'm going to start by subtracting 1 from both sides. So I have x minus 1 equals 7y. And then I'm going to divide everything by 7. So I'm dividing each term by 7. And what happens then in this first term is that I get 1/7 x. In the second term, 1/7 can't be simplified, so it's just minus 1/7. And then remember in this last term, that's where your 7's canceled and leaves y all by itself. The fourth step of this process is to rewrite the answer that you get. Now remember, your answer is this part over here. You're going to rewrite your answer in this notation, f inverse of x. That little -1 there means inverse. And then 1/7 x minus 1/7. And that's going to be your answer for 27. 28, change f of x to y equals x plus 6. Exchange your x and y, so x equals y plus 6. Solve for y, in this case it's one step, x minus 6 equals y. And then rewrite in function notation, f inverse of x is equal to x minus 6. Number 29, same process. Rewrite this with y equals 2x minus 4 over 3 stays the same. Then exchange your x and y. X equals 2y minus 4 all over 3. Now in this problem, it's handy to get rid of the 3 right away. So I'm going to multiply both sides of the equation by 3, and the 3's on the right side of the equation cancel. So now this whole equation says 3x equals 2y minus 4. To get that y by itself now, I need to add 4 to both sides. So 3x plus 4 equals 2y. And I'm going to divide each term by 2 so that the y is by itself. And I end up here with 3/2 x plus 2 equals y. And again, I'm going to write my answer in function notation. 3/2 x plus 2. Number 30, y equals 2/5 x plus 3. Exchange your x and y. X equals 2/5 y plus 3. I'm going to subtract 3 from both sides. X minus 3 equals 2/5 y. Now, I know that some of you were taught to multiply now by the reciprocal 5 over 2. I find that a lot of students have trouble with multiplying a fraction. So what I'm going to do is I'm going to break that down into 2 steps. And I'm going to multiply, first of all, on both sides by the denominator. So I'm going to take this and multiply it by 5. And I'm going to take this side and multiply it by 5. What happens here is just that the 5's cancel. On the left, I'm going to do the distributive property, and I get 5x minus 15 equals, now I still have that 2. The 2 is still there with the y, and so the 5x minus 15 is equal to 2y. Now I'm going to divide each term by 2 so that the 2's cancel with the y, and I get 5/2 x minus 15/2 equals just y. And so my answer in function notation is f inverse of x equals 5/2 x minus 15 over 2. Now, for 31 and 32, the process starts the same. You're going to find the inverse function for the given function, and then you're going to graph both of them on the graph given. So here I've got y equals 2/3 x minus 1. So x equals 2/3 y minus 1. Get the y by itself. X plus 1 equals 2/3 y. I'm going to multiply both sides by 3, which means that I need to distribute that 3 on the left. And so I get the equation 3x plus 3 equals 2y. And then I'm going to divide each term by 2. And my final y equals is 3/2 x plus 3/2 equals y. And rewrite it in function notation. F inverse of x is equal to 3/2 x plus 3/2. Now that's already in y equals mx plus b form. Remember that we want you to draw the line y equals x when you're graphing an inverse. So start by giving yourself that line through the origin with a slope of 1 and label it y equals x. And then next you want to graph the original function, which is what was given to you, and the inverse function, which is the equation that you computed. So I'm going to start with the original function, and I'm going to draw that in blue. Remember that it's y equals mx plus b, so 2/3 is your slope, minus 1 is your y-intercept. So put a point at the y-intercept minus 1, and then your slope is up 2 and over 3, so I'm going to put points up 2 and over 3, and then I like to go backwards and do be able to fill the graph space with the points that I'm gonna need for my line. And then my line, which I should be drawing with a straight edge, and you should be drawing on your paper with a straight edge. That's my graph of f of x. And now I'm going to draw the inverse function, and again, that's y equals mx plus b, so 3/2 is both m and b. So I'm going to put my y-intercept at 3/2, which is 1.5. And then I'm going to go up 3 and over 2. And again, I'm going to go backwards so that I can get a really good slope going on my line. And so my inverse function then should look like this. And I'm going to also label that equation f inverse of x so that your teacher knows which line you're graphing where. Okay, so number 32, same process as 31. I'm going to find the inverse of the given function. So I've got y equals 4x minus 2. So 4x equals 4y minus 2. And then I'm going to add 2 to both sides. So x plus 2 equals 4y. And then I'm going to divide each term by 4. Divide by 4 and divide by 4. And I end up with 1/4 x plus, now notice that 2 over 4 here, that fraction is the fraction 1/2, so it's going to be 1/2, and then the 4's cancel so that you're left with just y. Rewrite that in function notation, so now you've got f inverse of x equals 1/4 x plus 1/2. Again, we're going to ask that you graph the line y equals x. That's the line that goes through the origin with a slope of 1. That's the line y equals x. Then you're going to want to graph the original given function. So f of x equals 4x minus 2. In y equals mx plus b form, the minus 2 is the y-intercept, and the slope is 4, so you're going to go up 4 and over 1. And this, on this graph, there's not enough space to do more than just those 2 points, and it's a very steep slope. And then label that your graph of the function f of x. And then we're going to graph the inverse function that you just computed, 1/4 x plus 1/2, where 1/4 is the slope and 1/2 is the y-intercept. And the y-intercept is 1/2, and you go up 1 and over 4, and I can also do that backwards so that now I've got this line that has a very shallow slope, or not shallow, but it's not steep slope, and f inverse of x is the red line. When you look at the graphs of the functions and their inverses, notice a couple of things. They're reflections over the line that's green. So here, if you're thinking of the green line as a mirror, this line right here is kind of a mirror that the red and the blue are reflected over. And the other thing that you want to notice about any inverse situation, inverse function, when you're graphing the function and its inverse, that if they cross the line of reflection, they both cross it at the same exact place. So in that graph and in this graph, both of your lines crossed y equals x at exactly the same place. Keep that in mind as you look at the last problem, number 33. It's asking if the red and blue are inverses of each other. So the first thing that I'm going to do is draw the line y equals x on each one of these graphs. Y equals x, y equals x, y equals x, y equals x. Okay. Now, when you look at one of these graphs, ask yourself if the blue picture, or pick the red picture, were reflected over the green line, would it give you the red picture? And I hope in the first one that it's obvious that it would not a reflection. But when you look at that second graph, notice that the blue and the red both touch the green line, y equals x, at exactly the same places twice. And if you look at the blue line and how it reflects here to the red line that over here, that does happen over that green y equals x. And so this is an inverse function relationship. In this one, the same thing happens. They cross at the same place, and this part of the blue graph reflects to this part of the red graph. So these two, red and blue, this graph represents an inverse relationship. But in this next one, that I would say is more of a reflection over the y-axis, not over the line y equals x. So let's say no, that's not an inverse function. So in the top row, it's just these two in the middle. In the bottom row, the first one, because of points like this, and that you can see that this part reflects to that part, and so on. This is not, and this last one reflects over, yep, this last one. So the four inverse functions here are the second, the third, the fifth, and the eighth.